start to record. And then we are going to start. Today we will start with new topic, okay? So let's first explain the concept about what we are going to explain today. Why this pen? Okay. So today, on the textbook, I forgot which chapter, but I remember on my website, course website, I put the chapter also there. So if you want to read the book, you can also check with the website about the information from the textbook, okay? So here, what we are going to learn a new data structure, okay? We can call it abstract data type. So it's a data structure, okay? Some kind of data structure. Okay, let me see, data structure. That's also, so all sorts of data structure is a very important part in computer science, okay? And what we are going to learn today is about stack, okay? And previously you learned array, is it? An array list. So both of them can be used to store a collection of items. Okay, but they must be the same type. Is it? And with array, and you can store a collection of items. Okay, so that's one kind of data structure. Okay, and the stack. So over here, we also so generally speaking, data structure is regarding a collection of items, not a single item. Okay, so stack is also used to store a collection of items. Okay, same type. Of course, okay, but there is a feature is not like array or array list, is it? What it's going to look like, so it's something like this. You can view it like a container with the top end open, okay? Suppose we are going to store some books here, okay? A number of books. So this is going to be the first book. You dropped it to the container, is it? And then next, you drop the second book. But where the second book is going to be, is going to be on top of the first book. Is it? Okay, then next, the third book, if you want to drop, where you can store it, you can only store it on top of the second book, is it? And you can drop the fourth book, is it? And the fifth book. Okay, suppose your container size can only be used to hold 5 books. Okay, then it's full. You cannot add any new items. Okay, then, so this is how you adding, is it? How we adding new items. Is it? We adding new item is, how do we add? We add at the top. Is it? At the top of the collections. Is it? So each time, is it? The new item you're going to add is at the top of the existing collections. Is it? Okay, that's how we add a new item, okay? And then, who is the first book to be added? This is the first book. First book added. And where it is, it's at the bottom. Is it at the bottom of the container? Is it okay? And this is the last book. Added, is it? And where is it? It's at the top of the collection. Is it? It's at the top of the collection. Okay, so that's the adding part. Okay, so next, let's see. Okay, now I want to remove items. So now I want to remove book, is it? So when I do remove, I don't have enough space. So what is going to be the first book? What is the first book to be removed? Which book is going to be the first book to be removed here?
5.
Yeah, the 5th. Is it? The 5th book. Is it basically is what? Is the top book. The top book. Is it? And after I remove it, what's going to be the next book to be able to be removed? The 4th book. Is it? So the next top book. Is it? That's how you add and how you remove. Is it? So when you remove, in this case, so when I do remove, where can I remove?
In the end?
Yeah, the top, is it? At the top. Can you remove from front? No. Oh, not from bottom? No. Is it? Because you need to remove all of the top one. Then when only there is the bottom one left, then you can remove it. Is it? But no matter when you remove, you also remove at the top. Is it? So in this special scenario, is it? You can add at the top. Is it? Where did I? So when we add a new item, we add at top. Is it? When we do remove, we also remove from top. Is it? Because from visualization, this container, you can only access top. Is it? Only access at top. Is it? So this kind of concept, okay, so how do we understand this kind of thing? Is it? So this is, so we only access at one end, is it, of the collection of items. Is it? What's the end? It's the top. In this case, is it the top? So this kind of data structure, if you wanted to describe something that will be able to do something like this, we call it a stack. Okay, so based on what we just draw, is it? You add always at the top. So add at top. And when you do remove, you also remove at top. Is it? And the features you add at top, that's, so the top you add, and where is the first? Is it? So, and when you remove, you also remove at the top. You remove at the top the item is one that you last add. Is it? You add last. Is it? But the last one you add will be what? Will be the first one to be removed. Is it to be removed? So this is called last in, first out. So last in, first out. And we call it LIFO. Okay, so stack is a data structure that can be used to store a collection of items, and it has a LIFO characteristic. What is LIFO? It's a last in. So the item you add at last, is it, will be what? Will be the first one you remove. Okay, will be the first one. So that's the feature of stack, is it? So if you think about your array, is it? It doesn't have this special characteristic, is it? And for array, you can access any item, is it, through the index, is it? But for stack, there is no such way, is it? You got to remove the top item so that you can access a certain item that you want. Is it? Because it's last in, first out. And we can view it like a container with only one end open, because you can only access at the top. Okay, so this kind of data structure, we call it a stack. Okay, a stack. And so this is the basic feature for stack. So then next, let's see. So what's the basic for the basic operations? Okay. Let's go to that. Let's go to here. So what's next we are going to discuss is basic operations in stack. Okay, and based on what we just discussed, is it what we care about for stack is you need to know how to fill a stack. Is it just like an array? Is it you need to fill an array? Is it what we call that is you can add a new item? Is it? And where do we add a new item? It's at the top. Is it? At the top. And at the top, so this kind of operation regarding stack, we have a special name. Okay, we have a special name. We call it push. Okay, push. So push is you add a new item at the top. Okay, that's what we are interested. Is it? And we also interested in what? Remove top item. Is it? From stack. So that operation, we call it a pop operation. So you can remove an item, is it? And we also interested in knowing what? In know what the top item is. That operation, generally, we can call it a top. Okay, a top operation. Okay, so those are the three basic operations in stack. You add a new type item, we call it push, and you remove top item, we call it pop, and you retrieve the top item, we call it a top. Okay, we call it a top. And of course, we also want to know how to build a stack. So it's a constructor, is it? And generally speaking, you also want to know if the stack is empty. Is it? So that's also another operations. Okay, so those are basic operations regarding stack. Okay, and the next, let's take a look. And the first, before I move on to the next, it looks like there are a lot of chats. So let's see. Oh, that's nothing to do with our class, is it?
Yeah, they're not.
Oh, okay, okay. I just thought there are some questions regarding my class. Anyway, so if you have any questions regarding our class, make sure you just let me know. Okay, you can use audio. Okay, so that I know there is a question. Why I cannot do any drawing? Oh, okay. Now I can do drawing. So now we understand the stack. Is it? Stack. So let's have our first quiz question. First quiz question. Okay, so what is characteristic of stack? Do you still remember that four letter? That four letter?
LIFO?
Yeah, very good. Okay. So you need to send this. And what's the complete name? What is the complete name for LIFO?
Last in, first out.
Yeah, very good. Okay, so you can send this to our chat. Okay. So that's the first one. Second question, for stack, so can you access both ends of a stack? What both ends we mean? Bottom and the top here. So what is the answer for this? For a stack, the second question.
You can only access the top.
Yeah, very good. Okay. You can only access the top. Okay, so keep all this in mind. Okay. So that's our quiz question. I'm going to clear. Can I clear the question out? Or all of you still need it? Can I remove it?
Yes.
Okay, thank you. Let me remove it. Okay, so next, so what we are going to discuss. So we conceptually we know what a stack is it? So next is how do we implement a stack data structure? Okay, ADT, abstract data type. Is it? So today what we are going to discuss, we are going to use array. We are going to discuss the way to implement as array. Okay, and in the library, there are some other ways to implement. It can be built like from an array list, okay, or from linked list. There are other ways you can implement. So what we will discuss here is we implement use array. Okay, if we use array, then the stack has capacity. Is it because array has capacity? Is it? But if you do it with array list, okay, like what you're going to do in lab, then the capacity regarding this, we don't need to worry, okay? So anyway, so we are going to implement as array. So then what do you mean? Is it you implement a stack as array? So here, let's see. Suppose over here, we are going to discuss is about an integer stack. Okay, so we are going to have numbers filled in this stack. Okay, and suppose the array size is going to be 5. Okay, so the capacity can only allow 5 numbers, okay, for this array. And then in this case, so you can see we do, because you're going to use array to represent the stack, is it? So we already learned the class, is it class? So we can write basically a stack class, is it? So we can name it as stack, is it? So for this class, then for a class, you need an instance variable. Is it? So here the question is, what's going to be the instance variable? Is it? So we are going to use an array, an integer array. Array, okay. Suppose I name it as M array. Is it? And it's an integer. It's an integer. Is it? And of course, the size, if it's a size is 5, is it? Then you can do new int 5. Is it? So anyway, so I'm going to use this M array. Okay, so this is going to be my M array. Is it? M array. Okay, so I have the array. Then I can kind of draw with it only has 5 slots. Is that 5 slots? So okay, and then this responding to its index, because array has index. So what I'm going to draw is something looks like this. Is this? So this is the first element of the array, second element. So first element is it, and then second element of the array, is it? So that's easy to understand, is it? And then, so suppose now I'm going to fill this stack, is it? So the first number I'm going to add is 100. So 100 is going to be filled at where? At sub 0, is it? And then I'm going to add 200. So 200 where I can add at sub 1. Is it? Okay, then I add 300. So 300 I can add at sub 2. Is it? So you can see, okay, visually here I can add all the numbers. Is it? But the question is, how do you keep track of the location of the top item? Is it? Is it? Because you want to know where the current, the most top item, where it is it regarding this array? And we can see it's related with its index. Is it? So then because of this question, then regarding when we design the stack class, the instance variable, then here, let's see, how about we provide some positional index? Is it to keep track the latest index? Is it? So I can name it as mTop, suppose. Okay, mTop. And then the question is where you initialize this mTop. Is it at currently? So mTop, you can also see when you add 100, mTop is 1, is it? And when you add 200, mTop changes to 1, is it? And when you add the 300, mTop changes to 2, is it? So it's keep updating, is it? So that this is the top index. Top index, is it? And also based on the pattern, is it? Whenever we add a new item, the pattern of the updating of the mTop, we can kind of guessing it's what? It's increment by 1, is it? Increment by 1. If it's increment by 1, then what should be the initial value? Is it 0? If it's start at 0, then when you add 100, it's supposed to change it to 1. Is it? So the best value for the initialization is what? Is -1. Okay, this is kind of weird because index cannot be -1. But this doesn't matter, is it? Because when it's -1, so m top equals -1, it kind of it's kind of like what? It's kind of you don't have those. Is it? It's an empty one. Is it? It's an empty one. So that works, is it? And then when I, let's see, I need to change it to, can I still do this? Okay, I can get back to my pen. Okay, then you add 100, 200, 300, is it? Because see, when you add 100, you increment m top by 1, it's 0. Is it? And when you add 200 m top, increment by 1, it's updated to 1. Is it? So this works. Okay. So the top index you initialize as -1. Is it? As -1. And over here, the idea is let's do this. I just get rid of shouldn't get. So, okay. Okay, so why is it still that brush? Okay, so over here is each time when I add a new item, the operation, do you still remember the name of the operation? Whenever we add a new item, what is that?
Push.
Push. Yeah, very good.
Push.
Yeah, it's a push. Is it? Push operation. So regarding the push operation, when you write the stack class, is it? And for the push operation, what do you think the return type should be? So push, is it? And how about a parameter? In this case, you add a new item, is it? How about let me clear here, it's kind of messy, okay. So we already kind of understand the operation that I already draw. So over here, you have the stack, is that we have 100, we have 200, we have 300, is it? And for our stack class, is it? We have that array, is it? We have this instance variable array, as the size is 5, as the type is integer, as it? We also have the top index, is it? And it's integer, is it? So we understand these two, is it? Those are instance variable, and in this case, is it? So m top at this point is 3, is it? And for our m array, the sub-0 is 100, is it? Then m array sub-1 is 200, is it? M array sub-2 is 300, is it? So for the stack operation, for stack we just discussed, is it? The important operation is push, is it? And the push, what's the return type, you think?
Stack.
Not a stack. You don't want to return stack. Is it? What a push going to do? Let's see. Suppose now I want to add 400. What's going to happen?
Integer.
You see, I add the 400, that I drop the 400 to the container. What do you need to update? You need to update the top index. Is it increment by 1? Is it so top index update to 4? Is it oh no, I got it wrong. This is 0, 1, 2. I'm sorry. 2, this should be 3. Okay, I'm sorry. 3. Okay, so it's updated from 2 to 3. Is it? So that's one operation. Then what? Then you need to fill the fourth index. Is it M array sub 3 with 400? Is it? Basically,
is that what goes in the parameter?
So yeah, so the good question. So what should be the parameter?
Integer 400.
Yeah, integer, and you give the parameter name. Suppose it's called item. Is it? The type should be integer. Then my next question, because whenever you write a method, the most important thing is what? You need to know the return type of the method. Is it? Then the name, method name. Is it? And the following by parameter list. Is it parameter? And then you have the body part field. Is it? And of course, you also need to have public or a private something, etc. And the static or not. Is it?
I got a quick question.
Not the major thing. Yeah, please.
So is this basically a way to like dynamically add on or take off from
exactly
array? Because
very
in the
good
past
point.
I haven't understood how, like, because once you define it and say there's basically five I don't know, like elements in an array, I haven't been able to add or decrease. You just have to like keep it where it's at. So this is a way to like add or take away elements in an array without. Okay.
Yeah, excellent point. Yeah, so that's a very good point. Okay, so one of is, you remind me to mention one of the advantage for stack is that here, especially later on, we will see, okay, not at this point, it's dynamic. Yeah, you can dynamic add and remove. Is it adding and removing? Is it? Yeah, very good point. Okay, especially later on when we see if you implement stack with dynamic data structure. Array is not a dynamic data structure. The array itself is a static data structure. Okay, here static doesn't mean class static. It just means the size cannot change. Okay, later on you will see that when the size can change, yeah, you can still do adding and removing. But that's a very good point here. Okay, so one nice thing is you can dynamic. Yeah, please.
My other question was just, so when you remove one, is that still stored in the memory, or does that?
Yeah, very good point. That depends on how we implement. Okay. Yeah, in the way that right now we implement for array implementation, you cannot remove it. You cannot kind of wipe it out from memory. No, there is no way. So that's the next question I'm going to explain. So now for the push operation, what do you think the return type should be? Just guessing. Just think, do you want to return something here for this method?
Void.
What?
I said void. I didn't.
Yeah, very good. Yeah, very good. Super good. It's a void. Okay, because you don't expect it to return something. What you want to fulfill is, okay, I'm going to update the top index and I'm going to add some item to the expected location, is it? So that's why it's just a void. Okay, very good question. Okay, And of course, just think about it. Then I want to add another one. Is it 500? Is it? Then M top updated to 4. Is it? And then the question is, can I add 600 now? And okay, I forgot to mention the size is 5 here. Is it the array size is 5 capacity? Can you add 600? No, is it? Because you cannot add. Because what? Because already the array is already full. You cannot add. There is no empty space for you to add. Is it? Yeah, so you cannot add. So if we implement array, not array, if we implement our stack with array, we also need to take care of stack is full condition.
So if stack, so if it's held to the limits of an array, static, then why wouldn't you just use an array list? Why use a stack at all?
Oh, you mean why? Because for different features, based on different scenario, okay, we want to use a specific data structure that can best fit the problem that you want to solve. Okay, not just we just use a single kind of data structure that's going to fulfill everything. Yeah, because for stack, the features, it can only access at that single one end. Is it? And it's kind of, it's a hide everything. And that's also what you wanted to achieve, because later on we will also discuss some operation. And if you do you remember, if you recall, anywhere else we mentioned this stack word almost from the beginning of the class? Is it? We mentioned a lot of stack. Yeah, you remember that? Yeah, stack and heap. Is it? Yeah. So basically, stack memory, is it? That's kind of using this stack concept. Okay, so later on we will also see. Okay. The feature is you only access at that top end. Is it? And it has that special feature, we call it LIFO. So if it's last in and you wanted to get out first, then this is a best choice. Okay, this is one of the best.
Got another question.
Yeah, please.
So how do you specify that you're using a stack array and not just a regular list array? How do you specify you're using this data structure instead of the one that we've used in the past? Or is there a difference? It's kind of confusing to me.
Okay, so yeah, so here, because we just bring this new concept, it's kind of confusing, but later on you will get off this clear, okay? So anyway, so today what I'm trying to explain to you is about the stack concept. So stack concept right now, you kind of get it. It's LIFO, is it? And it's like a container. You can only access at the top, is it? That's kind of the concept. But because over here, because in real world, you can mimic it to use a container, is it? You can use a container to mimic. But just think about, in computer, how does it know? How do you get a container? Is it? So you needed to use some kind of underlying existing data structure to mimic this stack concept. So that's what we discussed, is we discuss implement. We're going to implement stack as a class class, we already know it's just a blueprint, is it? To categorize certain objects, certain category of object. So we are going to implement as a class using array. Okay, using array. And then later on in your lab, you're going to see you can implement them in array list. Okay.
Okay.
And then later
I think I was just confused because I thought that this array was any different than the arrays we've used in the past. But
array.
It's the same thing. You're just using this concept.
Exactly. Yeah.
Okay. All right. That
Yeah.
makes
So
more
got
sense.
it? Yeah. So when you have a lot of item to store and you don't expect that your storage is going to dynamically grow or shrink, is it? And what you care, so it just depends on what you care the most. You care most is suppose big access individual item with their location, then the best choice is array. Okay, or array list. Okay, if depends on if your collection of item size changing. Okay, because what? Because the quick accessing. Okay, but today what we discuss, okay, we want some application that only access at top. So I just want to have that kind of privilege, is that I'm going to be the last in line, but I'm going to be the first to enjoy the service, is it? Then you can use stack, is it? So that's kind of like the unfair thing for airlines. The VIP got the boarding last. Are they boarding last or first? I forgot. But anyway, so it's not in order. Is it whoever last in line, but they get the first to be served. So if you want to have some application have this special feature, then you use a stack. Okay, and a very good point is that here we just want to basically over here we use array as we wrap array, is it? So that it can demonstrate this LIFO characteristic. That makes sense?
Yeah.
Okay. Okay,
So
then.
I got one last question for you.
Uh-huh.
So even when we're implementing this, the stack data structure, you still have to define the size of the container, and that can't change, correct?
Yeah, exactly. If you use array to implement.
So let's say I create an array that has room for 25 elements, but I start out by only putting 3 elements into the container, and then I slowly add to them. Would there still not be empty elements in the container that still hold a spot, but wouldn't you have to access those before you can get to the bottom? Because even though they're empty, they still hold a value of 0 or true, right?
Yeah.
Or false, sorry.
So depends on your decision about stack size. Is it? And generally speaking, here we consider the stack size determined by array capacity, because we implement with array. So if your array capacity is 25, then your stack capacity is also going to be 25. Okay, 25, that just mean you can add numbers, is it? Suppose you only add 3 numbers, then that means you have 22 empty slots. And you can still add 22 more numbers here. Did I explain your question?
Yeah, I think so.
That makes sense? Yeah.
Yeah.
But you have a good question, but today we run out of time. But tomorrow I can answer you. Yeah.
Yeah, no problem.
Yeah. Is it over here we got all the way to 2,500? Is it in this case? Then I know your question is, after I remove 25, after I remove 2,400, is it? But in that array, is it sub 24 is going to be 2,500, and M array sub 23 is going to be 2,400. Is it? There is no way to wipe them out. To wipe out, is it on heap? Because that's on heap, is it? So on heap you have 100, 200, is it 225? There is no way you can wipe it out from heap, is it, with array implementation. Okay, there later on we will learn other data structure, then you can see you have some way to wipe it out. But over here there is no way to wipe it out, is it? No way. So that number is still going to be on heap with this array, stuck with the array. But you remember we have this top index. We have top index to mark where your top item is, because now regarding your stack, this is your top index. So even though those two numbers are in heap, but it's not in your container. Okay, but of course this container is logic. Okay, there is no other heap space for the container. That makes sense? Yeah, so that's the idea. Okay, so it may be a little bit of confusing today, but we will come back to get a better idea tomorrow. Okay, we kind of run out of time.